So understanding the level of risk by African governments is minimal. A lesson to learn from Haiti, for instance, the Haiti earthquake was magnitude 7, while the Chile earthquake in the Andean mountain range was 8.8 or something like that, but the casualty in Haiti paralyzed the whole nation till now. So that's the difference in preparedness. So that's a lesson to learn for African governments also. This is the Karonga earthquake damage in Malawi. There were considerable damage on infrastructure and on the locals. So if we list the major earthquakes that has occurred significantly in Africa, 6.8, 7.4, 6.9, 7.1 in southern Sudan, and the recent Mozambique earthquakes. I mean, these are really, some of the earthquakes, if they occur today, they can really cause huge, huge damage in many cities and infrastructures. The point that I would like to make on this slide is traditionally the African small tukulu houses were very friendly with earthquake ground motions. But without understanding the risk we are getting into, I mean the vulnerability, many skyscraper buildings are being built in Africa without understanding what costs us. So in many African cities, small towns that we used to know today, they are becoming cities. So really the preparedness is very, very scary, very scary. This is just a building in Addis. Now it's finished, I think. So the structure and all, just Addis is close to the East African Rift, just at the rim of the rift. And the activity going on the preparedness and mitigation strategy is very scary. I'll show also another two examples, very interesting. This is just a triple junction in Afar. The Gulf of Aden Oceanic Rift comes in here. The Red Sea Oceanic Rift also comes in here, and the East African Rift joins to make a triple junction there. So, but interestingly, we tried to advise the local government and the federal government. There is a town in the development stage. I mean, there is a town expanding just after the triple junction. And as an expert in the region, we try to advise the local government and the federal government. It's not the right place to make infrastructure development there. But at times, you can be considered as anti-development. This is also another a dam just as a triple junction for irrigation purpose. About 100,000 people are at risk downstream. There are a lot of people living there, nomads. So the challenges in Africa, mega cities of rapid population and economic growth are emerging close to active rift margins in sub-Saharan Africa, with least awareness on the imminent earthquake and volcanic hazard. Sub-Saharan Africa is unprepared to face earthquake threats, and the national development could be crippled by large earthquakes of, say, MW 7.0 if it occurs quite close to a huge infrastructure development site where most of the African towns and cities are placed. The other problem is leaders in sub-Saharan Africa give priority to other issues. Even donors, they just don't hear in most cases. So food security, drought is just the issue. But this is another potential hazard that the continent is under pressure. Again, on the challenges, there is no institutional network in place in many African countries for mitigation purpose in terms of crisis. If I take my country, Ethiopia, for instance, once in a while we interact, but if something wrong happens with the monitoring facility people or seismologists, we analyze the data and to whom we should report. There is no really a framework on the ground for mitigation network structure. So that's really one gap which applies for many other African countries also. And monitoring facilities and capacity of research institutes are poorly equipped in Sub-Saharan Africa. Brain drain and monitoring facilities or instrumentation, other colleagues of mine will comment on that. As information is booming, local people in remote villages know what's happening in the rest of the world. I'll tell you an example in this regard. During the Fukushima crisis, Today, in many African remote villages which you may call, they can watch cable television and they can see what's happening in Japan, for instance. So immediately after the Fukushima crisis, there was a small earthquake 5.0 in Ethiopian, the Irigalem area, highly populated region. So they have a little knowledge of this part of the rift is one day it will be an ocean. And they heard also the Fukushima crisis. So when they felt the earthquake, then they decided, today is the day, that's our turn. Huge and thousands of people were displaced from their locality, so we have to go there and do some stabilization or outreach purpose. And I think we succeeded in convincing them and make them to go back home. And investigate the existing data. This is really the point I would like to stress. There are on the way forward, there are 2 points that I would like to stress. Investigate the existing data to better map the hazard and mitigate the risk. So this is where we are trying to be on board with the umbrella of GEM, with least capacity in sub-Saharan Africa in analyzing data and facilities, tools, and all these things. That is where we are into the picture of GEM. And the other one is build capacity in reliably archive the current data and future Earth activities. That's just for the future. Here I'm showing you the hazard map of GSHAP. And one huge problem is this hazard map was somehow underestimated, and even that map was not used properly in many African countries to revise the building code. So that's really a problem. Now, it has been 20 years since this map was produced. Now, the GEM initiative is just trying to pull experts around the region and put things together and revise this map and apply a revised seismic hazard map in the continent. And that's really something, because many of the African scientists and experts are isolated. Even some of us are underpaid, and sometimes we may be forced to drive taxis or something. So that is a sort of umbrella we have to embrace, and we are still trying and moving in the right direction. So to GEM is the kind of song that we are trying to sing at the moment. So the Sub-Saharan Africa Working Group categorized into 4 sub-regions, like the Western Africa region here. Morocco is included wrongly, and Central Africa, the East African region, and Southern African countries. So we are formed a working group. And then the hazard and regional components. Currently, we are working on the earthquake catalog, and we are supposed to do on active faults and source databases, ground motion prediction equations, and geodetic strain rate model. So this demands a lot of pulling expertise and also funding. But the funding part is not really rosy enough. We are still struggling, and the kind of support we are expecting is, compared to other stuffs, is really the standard deviation of funds for other disasters or something. So I think I have commented on this. I'm seeing a red line here. So this is the other, as a continuation of what to do next. And now is the capacity building. This is just a workshop that has been conducted in Zimbabwe, on data analyst workshop to build capacity in the region among ourselves. And this one is also an initiative by the international community to launch a PhD program in Sub-Saharan Africa. And almost most of them are crippled by funding and other problems. So thank you for your attention. Thank you.
I think we'll have the questions at the end. If I can get the assistance of one of the technicians. Okay, he's coming. Well, I take these extra seconds to, of course, introduce properly the previous speaker, which I did not do. So Dr. Atalaya Eli is a professor at the Addis Ababa University, and he's also currently acting as an operations manager in the GEM initiative. And our next speaker is Dr. Dumizani John Altayo from the National University of Science and Technology, Bulawayo in Zimbabwe. So, Dumizani.
Thank you. I'm going to look at the issue of challenges in capacity building for hazard monitoring in Africa. I'll just give you a brief background. In the 1960s, there are a number of stations in Africa which participated in the WWSSN. And it looked like as if we were on course. And of course, we were moving in the right direction, a number of countries, as we were taking part in this activity. And then notably, for example, in the ISASWAG, National Laboratory started putting up networks. And at least we were managing to put up at least 3 stations, which would enable us to locate the event where it happened. And since the 1990s, each of the 9 countries in the ISASWAG region, taking that one just as an example, have managed at least to train not less than 3 scientists to MSc and PhD level in seismology. We need also to take note that the bulk of credible data that is available is found in catalogs that were compiled by research organizations from outside the continent itself. And the largest reliable local data is for short periods of monitoring that we're using temporal stations. And the station location was actually not coordinated within the region. Hence, if you look at the station distribution on the African continent, you'll find that there is no uniformity. As a result, you get poor data in terms of temporal distribution as well as spatial distribution. I will now move on to the challenges that we face within the African region. And these challenges basically affect our operations in seismology. And consequently, they also hamper us from carrying out a hazard analysis. The first one to look at, basically, I've classified them as 4. The first one is high rate of turnover in personnel. And then the second one is to do with poor station coverage. And then the third one is inadequacies in software. And fourth, inadequate finances for collaborative research. Looking at poor station coverage. Poor station coverage actually feeds into a result of poor national or regional data being stored at the data centers. Now, this is as a result of different equipment being used within the region and different acquisition systems that we're using within the region. And then we also have an element which compounds it, which is poor station maintenance. And the poor station maintenance is as a result of inadequate finances for equipment spares. And another element that I'm going to touch upon later. The result of all this is that we have seismic event mislocations. And we've got incomplete catalogs within the African region. And this weighs heavily upon our work when we try to do seismic hazard analysis. Right, we've talked about poor seismic hazard analysis, which also is accompanied by poor vulnerability and a lack of risk analysis within the region. How does this come about? It's basically as a result of the poor computing skills in software development that we have within the region. And because we have got these poor software development skills, we tend to depend upon software that has been developed from outside the region. And some of the software that we use may not be on the open source software, and may be very expensive. And as a result, we are not able to buy the software. We will do with the software usually which is not non-professional, and of course it will give you substandard, may give you substandard results. That is, of course, compounded by the fact that the finances are inadequate to buy the software, and that is required to do the analysis of the data. Now, I turn on to the high rate of turnover for personnel. It's actually telling us we have got a high loss of personnel to the diaspora. When we are talking about personnel, those who are going out, these are trained scientists. And the trained instrument technicians, whom we require to maintain our seismographs. But we can proudly say, we have got a large reservoir of seismogram analysts, perhaps just because they are not in very high demand outside the region. We do also still have these seismogram analysts moving out to places like Vienna, CTBTO, and when they go for training, if somehow there is an opening, they apply and are accepted, and we have lost them. The same applies with the scientists whom we train within the region. And remember I said at the beginning that each country, at least each country in the ESA-SACUD region, which accounts for about 9 countries, we have trained not less than 3 scientists in each country. And that would give us a total of a minimum of 27 scientists. But one would like to find out, to take stock and find out whether all the scientists who were trained within a particular country are still available in that country. There is a tendency to move out looking for greener pastures. But then we'll talk about inadequate finances. Right, inadequate finances lead to a lack of equipment spare parts. And when you don't have the spare parts to repair your equipment, the result is a long station downtime. And that results in loss of valuable data that you need. It will also lead to, inadequate finances will also lead to staff migration. People would like to migrate to another place where they can have more money either into their pockets or more money for them to carry out their research activities. And the last arm tells us lack of finances plays down on the regional collaborative research. And when there is no money to carry out collaborative research, again, personnel move to where there is money. Question is, what is the way forward? A, I suggest that we need to enhance our regional collaboration. Collaboration within the African region, so that we can assist one another as networks within the region in order to upgrade or to improve the state of our data. Second, we need to foster collaborative research with institutions in developed countries. Perchance they may assist with the much needed equipment and software. And then the third one is engage in vigorous advocacy, lobbying government to support seismic research work. You know, the reason why there is very little money coming in is because seismology or hazards that emanate from seismology are not taken very seriously by most of our governments. They would rather look for money in order to feed the people there and then, or instead of waiting, pushing money into a sector where they will have to wait. You will have a disaster coming in once in 5 years or in 10 years. And lastly, we need to ensure sustained training program for all classes of personnel for research work. That way, I think we'll be able to mitigate the challenges that we have got in the region. Thank you very much.
Thank you, Dumizani. So these first two presentations sort of focus on the needs and the difficulties and challenges. So they did have a bit of a negative connection and tone that touched them. And so now we'll sort of turn the tide a little bit and see what are some of the possibilities of things that we can do to address these needs and the challenges that were just being discussed. And with this in mind, I will call now Dr. Helen Crowley from the GEM Foundation to the floor to explain us some of the possibilities in order to move forward.
Thank you. Good morning, everyone. So I'd like to talk to you a little bit about this global initiative, the Global Earthquake Model, and how we hope that, as Rui says, some of the activities that we're currently focusing on could be used by the regions such as Sub-Saharan Africa, how they can be leveraged on for addressing some of those needs and challenges that we've just heard about. So we know that seismic risk is a global issue. We know that there is large levels of seismic hazard all around the world. There are earthquakes occurring near large megacities. Recent earthquakes have produced very high levels of economic loss and fatalities. And we believe that we need a global solution to address such a global problem. These earthquakes that occur in different tectonic regions have many similarities, and we can learn from those earthquakes which are occurring in other parts of the world. Almost all countries in the world have the problem of lack of data, and so we should pull together the data from different countries around the world so that scientists and researchers can work on this data and improve our knowledge of seismic hazard and risk. We can also learn from damages to buildings in other parts of the world. There are many similar building typologies that are being constructed around the world, and perhaps in our countries we have not seen damaging earthquakes in the recent past, but we can learn from earthquakes occurring in other sides of the world. So that's why we believe that we should bring together scientists and researchers around the world to address seismic risk as a global problem. So this is why the Global Earthquake Model has been set up. The Global Earthquake Model is a public-private partnership, so it addresses both the needs of the public sector and the private sector. It brings together the strengths of these two sectors. Our motto is really that we're working together to assess risk, to assess seismic risk, and we're leveraging science for the benefit of society. Now, the three main activities that we are focusing on at the moment in GEM are global projects which bring together standards and databases at a global scale. Then we focus down into regional collaborations, bringing together the experts at a regional scale to then review these global standards and apply them regionally and enhance the work that has been initiated at a global scale. And then the third main activity is on developing open source software and tools that can be used for assessing seismic risk and helping us to make decisions to mitigate that risk. This is the framework, the scientific framework of the global earthquake model, how the activities are proposed to be structured within the fields of hazard, of exposure and of vulnerability. This can be physical vulnerability, so considering the damage and loss of buildings, but also social vulnerability, how the factors of society can influence, can acerbate the risk to which we're exposed. And then we can combine these different pieces, these different components within an integrated risk assessment, and we can use the outputs of that risk assessment to support decision making. So that's the way that we've organized ourselves on a scientific basis. In order to implement this at a global scale, we have organized the globe into a number of regions. Well, it's really the regions themselves that have organized themselves, and this is the current status and the way in which the world has been separated up into a number of regional areas where activities are taking place. Now, we believe that within a region, all of the countries need to work together. All of the experts within those countries need to work together because, as we know, earthquakes do not know political boundaries, and so faults cross political boundaries. And so the scientists and researchers in those neighboring countries need to pool their data and their knowledge and their expertise to make sure that we're modeling the hazard and the risk to the best of our knowledge. So this is exactly what we're doing in GEM. We are working with regional experts. We are organizing a number of workshops. So to begin with, we invite all of the experts within a region to come to the workshops to discuss what is the state of the knowledge of seismic risk in the region. And we've had a number of workshops in sub-Saharan Africa and also in North Africa. And so, as I say, the idea is to discuss what data do we have, where are the gaps, where do we need to improve in order to improve our assessments of seismic risk. So, at the same time, we have an initiative to develop these global standards and databases. And this is just a list of all of the different types of data that we might be talking about. We're looking at a global instrumental catalogue, historical catalogues, data on faults, on active faults, geodetic strain, looking at ground motions from around the world, looking at the exposure, the different building types which are in different countries around the world, the consequences, collecting data from past earthquakes, putting that into a database so that we can learn from what has happened in the past, physical vulnerability, how is the damageability of different buildings around the world, and so on and so forth, social vulnerability and resilience. So all of this data and all of the standards in order to collect that data and describe it in a consistent manner are being put in place. And then we're using all of that data to produce global estimates of hazard, of damage, of probabilities of loss, of cost-benefit analysis for retrofitting and insurance, and then also in combining physical and social estimates of vulnerability to calculate integrated risk. So let me just show you a couple of the global databases which are almost complete or are complete in terms of a first version. Of course, they will never be complete. We will release these first versions of these global databases, and we will need regional experts to review them, criticize them, and improve them, and so that we can keep these databases sustained. So this is a global strain rate model, and what you're seeing there in red is data which was available up until a few years ago from the literature. And then, thanks to this global project that GEM has started, you see the points in blue that have been added to this database. So you can see some parts of the world which had no data before in terms of geodetic strain have now got data, and that's particularly the case in sub-Saharan Africa. Another global database, first version that is ready, is the GEM ISC Instrumental Catalogue. Now, this is a catalogue where the way in which earthquakes are described within the catalogue at a global scale is harmonized. So we have a harmonized way in which the magnitude is defined and calculated, the location, and the depth is defined, so that we can use such a harmonized catalogue to calculate hazard at a global scale, which is comparable. But this includes 20,000 events, this catalogue, but it only goes down to a magnitude of 5, and so obviously it needs to be enhanced through regional participation and expertise to bring that to a lower magnitude threshold, to add the data which is available at a regional scale. So all of this data that I talked about, these standards, these products which are being produced, are going to be openly available on a platform that we called OpenQuake, which is going to be released in 2014. So this is a web-based platform. So we're developing open source, web-based GIS tools. If you go along at 1:30 today at lunchtime Ignite session, you'll see one of our colleagues talking about this open source GIS mapping tool, and in particular how it's going to be used to collect and crowdsource information on active faults. So one of the features of this tool of this platform is a tool that allows geologists around the world to upload their information on active faults, so we can pull that information together and share it. And another thing that will be within this platform is a set of tools, a number of tools to allow you to develop models. This is just one of the many tools that are going to be developed. But this is an example of a tool that allows you to develop a social vulnerability index or a resilience index by combining another number of indicators. And the tool will allow the users to change the weights that are being applied to the indicators to decide if they want to give more weight to, for example, the dependent population over 60 as opposed to the investment in education, for example. So looking at these different indicators, which might be an indication of social vulnerability, changing the weights and exploring the way that this influences the indices of social vulnerability and resilience. The software is another open source software. Is another part of our activity, developing software to allow you to calculate seismic hazard and risk. This software is actually, as we speak, being used to calculate hazard within Europe. So the calculations are currently running for the whole of Europe for a seismic hazard assessment. It's been tested and used by over 150 people from 40 countries. It's still within a development phase, but we've decided to release it so that we can get that feedback and make sure that it's doing the calculations that are needed. So here's the website if anyone is keen in having access to this software. And then we're also at the moment undertaking a number of workshops, technology transfer workshops, to work with people on using this software and these tools. We've had workshops with colleagues from Central Asia, also Indonesia. There's a workshop coming up in a few weeks. And then on Thursday here, we have a workshop with our sub-Saharan African colleagues to use OpenQuake and these tools. A final activity which might be of interest for people that want to get involved in GEM and within these regional activities is the collaboration platform Nexus that we've developed. And we have at the moment pages for a number of different regional activities, and people can sign up to join those groups. And we have discussion fora and places to share documents and notes and thoughts and share comments. So just to close, 10 minutes is really not enough to talk about GEM and the global earthquake model. So I invite you all to please come and talk to us either in the panel session that we have now, or come to our stand and just ask us more about GEM and how to get involved. Thank you.
Helen, thank you very much. Thank you very much for this. And we'll have now our last speaker, Dr. Ray Durham from Africa Array and the Council for Scientific and Industrial Research, who sort of close the picture in terms of what is it that we can do to address the challenges and the needs that were presented with the first two talks. And we have a security alert here.
Thank you, Rui. It was here in Cape Town in January 2009 that the International Association of Seismology and Physics of the Earth's Interior had its General Assembly. And it was there that we, the African seismologists, first heard about GEM. And in fact, we had an ad hoc meeting. We got all the African seismologists together, and we found out what this program was. And was really exciting. And I think it gave us opportunities to get involved. And what I'm going to report on now is really what's happened since then in order to make use of these opportunities and get on this boat. So what I'm going to talk about in this right here is really what initiatives are there currently to mitigate earthquake risks in Africa. GEM didn't come into a vacuum. There was stuff happening here. What are the objectives of the regional program? What benefits and opportunities are offered? And what is our status? And where do we go from here? Well, as John has already said before, there's an association of seismologists in Eastern and Southern Africa, and they've been working together for several decades here to try to build their systems, build their infrastructure, and build their capacity. More recently, a program called Africa Array was started. This was in 2005, and this is a public-private partnership to build capacity and infrastructure in Africa. What we've been doing here is refurbishing seismic stations that have fallen into disrepair and also establishing new ones. Currently, we have our backbone network consists of 44 seismic stations in sub-Saharan Africa. Some of them have got continuous GPS stations as well. And we also recently have been adding weather stations to some of these, so it's taken us also into other areas of science, such as atmospheric science, hydrology, climate change, and space weather. This project is largely funded, again, by the American NSF and the South African National Research Foundation. Just to give you an example of some of the work that's come out of this, Atalay already mentioned that in 2002 there was this volcanic eruption where lava flowed through the streets of Goma in the DRC. The Goma Volcanic Observatory has seismic stations on the mountains to monitor the seismicity that gives you a precursor, a warning of the seismic of eruptions. And on the side there you see George Mavonga over there standing in front of the signboard in Goma where the flag is flown to give you an indication of the level of hazard. But George, for his PhD, not only looked at the seismicity associated with the volcanoes, but he also looked at the seismic hazard in the DRC as a whole. And you find that along the western branch of the East African Rift, from time to time, earthquakes bigger than magnitude 6 occur. And he produced this seismic hazard assessment, and since then we've been consulted by agencies such as the High Commission for Refugees to get guidance as to where displaced people should be settled. We've also been approached by mining companies who are opening gold mines in that area, first to find what could be the effect of earthquakes on underground workings, but also on the slimes dams that are built near the surface. So clearly there's a need for this type of information, and we are working on that. Also, another initiative is the International Council for Science. They have a regional office for Africa, and one of their initiatives over here has been to identify areas where science is critically needed to solve African problems, and we're working on a program to look at natural hazards and disasters in sub-Saharan Africa. This initial pilot phase is funded by SIDA, the Swedish International Development Agency, and part of this is looking at geohazards such as earthquakes, volcanoes, and landslides. Then, in other areas over here in South Africa, there's a view of Table Mountain over there, and just across the bay is South Africa's nuclear power station, the Koeberg Nuclear Power Station. And clearly, before you build a nuclear power station, you need to make sure you understand the seismic risk adequately. And South Africa is currently looking at building another 4 or 5 nuclear power stations. And while South Africa is not really exposed to a high level of, you could say, big earthquakes, when you're building a nuclear power station or a nuclear waste disposal site, you've got to make sure that these are secure not just for a generation, but for centuries or tens of thousands of years. So really understanding your seismic risk becomes very important in situations like this. Another situation we face here in South Africa are our seismic events that are triggered by our deep mines. We have gold mines that go down to depths of 4 kilometers, and we make our own earthquakes over here. The biggest one we've had so far has been a magnitude 5.3 event, and several thousand men were trapped underground and evacuated, and of course quite a lot of damage was done to buildings on the surface. So this is an issue that we have to face as well in this country. Another activity at my university is again looking at how we can build low-cost housing over here that can withstand seismic shaking. And we have a shake table over there, and a system has been developed where we have almost Lego-like bricks that fit together and interlock and can be made to withstand reasonable levels of shaking, and also ways in which to retrofit and reinforce housing of this type. So what are our challenges in sub-Saharan Africa? Some of these have been mentioned before. We've got these incomplete and uncertain seismic catalogues. Our coverage of seismic networks is rather sparse. Our knowledge of active faults is also not so good. And as has been mentioned before, we have a shortage of skilled technicians, seismologists, and engineers. So challenges are significant, but we're not standing still. We're trying to address it as best we can. And here, GEM gives us this opportunity. The regional programs over here, the idea is to gather together the earthquake practitioners and seismologists from the region and to work together to pool our knowledge, build our capacity, and most important, that we can leapfrog and get involved and learn the latest technology. That in future, if we're on board here, we won't need to bring the consultants in from California or Japan or Italy. We will be able to do the work ourselves with the tools that we've been given and the training that we've had. Also, the opportunity is that as the GEM teams, the global component teams, come up with procedures and standards, we are being given the opportunity to comment on them and make sure that the procedures that are given are adequate and take into account African situations. It's no good having a procedure that works in Tokyo or California, but it doesn't work in Africa. So we have the opportunity to comment on that. Also through training exercises like we're having right here. After this meeting on Thursday, we've got the opportunity to learn about it. And so really the challenge is for us, and there are quite a few African seismologists and earthquake practitioners here, is to come on board and learn how to apply these tools to reduce the earthquake risk in Africa. And in this way, and certainly Africa, we hope that there'll be a trajectory of increased growth, that will be seen, modern infrastructure being built here, nuclear power stations, new mines, new roads, new dams. We need to make sure that we build these things safely. So our milestones, as I said, this really started off in 2009, January, here in this very building. Since then, we've had our first GEM Sub-Saharan workshop in Kenya. And from there, one of the things is that GEM Foundation kindly put the money up to appoint 2 operations managers, Dr. Mohammed Al-Gabri from Egypt for North Africa and Dr. Atalay Ayeli for Sub-Saharan Africa. And they are now leading the initiative to really mobilize our African seismologists. And so we work together, and at this meeting here, we're trying to enlarge our pool of people who will become members of this initiative and get involved. So what are our plans ahead? Firstly, we're currently busy contributing data to the global component teams, contributing information on historical seismicity, instrumental seismicity, what we do know about active faults, and what we know about the way in which seismic motion is attenuated in our crust. We are evaluating the global component outputs as they get to us in the next couple of months, but also an important role that we've got is to raise support to expand these regional activities. Currently, we're really leveraging what has been done in our universities and geological surveys, and really we want to raise our effort to another level. And then over the next couple of years, the challenge is to transfer these GEM standards and technology and apply them to our situation, to have pilot studies where we'll be using the OpenQuake tool to assess seismic hazard in our countries, to map active faults according to the standards and procedures, and to also assess vulnerability in some urban areas, do some case studies. So we formed a management committee with a role to manage the general affairs, do fundraising. We have a scientific committee to comment on these standards and procedures, and also we've been divided into various sub-regions. And over here, you won't see this over here, but we've populated out a diagram. These are the people who've agreed to take on these roles and responsibilities. So in conclusion, over here, we're in Cape Town. There's a harbour just down the way, and I have a sense that the GEM ship is sailing. It's been here in port, and we've got a whole lot of stuff we've already done, so we can get a ticket to go on board, but we don't want to miss the ship. So, I mean, really, if you're interested in earthquakes and you want to reduce the risk that earthquakes pose to us here in Africa, this is the time to come on board, meet us, get your ticket, so you can sail along the ship as well. Thank you.
Thank you very much, Ray, for wrapping up in this tone. Just what we need for our roundtable now. So what I would like to do is to invite the speakers to join us in the roundtable, plus as well Mohammed Al-Gabri from Egypt and Nicole Kell from the GEM Foundation in our roundtable. And now this is when the session really starts, which is when you have the chance to contribute, to comment, to question, to raise difficult questions, to put our panelists on the spot. So that's what I think I can do is perhaps to give the floor the chance to throw in 2 or 3 questions, and so we group 2 or 3 questions at a time. We get the floor to address them, and then we go to another set of 2 or 3 questions. So I believe there are mics available in the room for those who want to speak and intervene. So I think the panel is ready, all set to go. So I think we can start. Questions from the floor, questions, comments from the floor. I can see we're feeling a little bit shy to get things started. Okay, I have.
Thank you. I have a question on the challenges that the region or continent is facing. It sounds like in terms of scientific stuff, we're losing quite a lot of people. Are there any efforts being made to collaborate with those scientists that are leaving the continent? Try to find out if they can contribute even from those countries or areas where they are now. Is there any way you can work with them to improve our knowledge of seismic hazard on the continent?
Thank you for that. Do you mind just presenting yourself?
I'm Vunganai Midzi from Council for Geoscience here in South Africa.
Thank you. Another question before I pass on to the panel? No, so I'll okay, another question there, and then we pass on to the panel. The microphone is arriving. If you please present yourself.
I'm Mulkan from Ethiopia. Just as an opportunity and risk, for instance, this Rift Valley Strait to the Red Sea, as you know, there is active volcano. As an opportunity, GEM, what is going to advertise for this as some tourism attraction and as a economic benefit rather than a risk? Of course, I know that you are working as a risk understanding for that area only.
Thank you very much. So I think I'll pass it on to the panel. Perhaps John or Atalay would like to address the first question regarding have we made efforts to interact with those scientists that have left the region, have gone and worked somewhere else. John, perhaps?
Thank you. I would like to say yes and no. Yes, in that we do have scientists who have left certain positions in certain countries whom we are still in contact with, and we are working with closely. But we also have a number who have left, and when they leave, mostly, as I've said, they either leave for greener pastures, and when they are there, sometimes they do actually forget that they have left us behind. And those who remain behind, manning the offices where the positions which they have left, they are usually inexperienced, and it does take time for them to come to a stage where they can think of the fact that they need to collaborate with their colleagues who have left, even if they are away from the country where they are working.
Helen, you wanted to comment on this as well?
Yes, I just wanted to comment that I believe that being involved within a within a global initiative such as GEM, we can help that collaboration between different regions. So at the GEM Secretariat, sometimes we're contacted from researchers. I was recently contacted by a researcher who's currently in Canada, but is from sub-Saharan Africa, asking me that he would like to get involved in activities in Africa. So we can play that role of helping different experts around the world to work together, even if they've left their regions.
Thank you. So if we can pass on to the second issue, and perhaps I would invite either Atalay or Ray to respond to the second point that was raised.
Tourism attraction, yes. Well, I think there is a limit to what extent GEM get involved in assessing the hazard in sub-Saharan Africa. But the tourism part is just up to, say, for instance, the Ethiopian government and experts to use that opportunity for tourist attraction or something. So, I mean, that's more of a national agenda or issue. But GEM is trying to pull together experts in least capacitated countries in sub-Saharan Africa, put them under the same umbrella and provide them standardized software and many more other supporters to assess the hazard. And there is a limit that the GEM just stops basically. So that's up to that country to use opportunities by its own.
You know, but I think the point you make is well taken. I mean, we're interested in the development of Africa, and if tourism is a major income bringer in many countries, African countries in East Africa, and if we can use this as a draw card, we need to take advantage of that, certainly. And but tourists need to stay safe, and we climb a volcano, then we mustn't do it when there's a eruption due to happen. So in that sense, I can see that warning systems have a role to play in tourism as well, and making it an attractive destination.
Other comments? So can we have a microphone here? And then we'll go there.
Thank you. I'm Saurabh Dani from the World Bank. Just kind of if you can give us some more information about, I think you mentioned loss exceedance curves and information about economic losses that GEM is kind of subsequently building on. And my sense is that there is also links very strongly back to building classifications and those kind of informations in specific regions and countries. So what are the efforts that GEM is taking, or even regionally in Africa they're taking to kind of meet these needs? Thank you.
Thank you. So we can have another question from there. And then there at the end.
Thank you. I am Alan Tokam from Cameroon, University of Yaoundé 1. John mentioned all the problems we face in Africa for risk, particularly earthquake risk management. But I don't know. You don't think so? Maybe African scientists should also start to be involved into political affairs, because I feel that most of the problem is that politicians do not understand what we are doing. So if scientists could also try to learn about how to enter in contact with politicians, we can improve our fundings for research. It is a track for us. I don't know.
Okay. Thank you. And we have one more question from the floor, and then we'll pass to the panel. Over there in front of me.
Thank you. I'm Scott Carstens, the current president of the Disaster Management Institute of Southern Africa, and I'm also a director for risk reduction in the Western Cape. I just want to pose a question to Ray. We are, as disaster management practitioners, not line functionaries. So we are there to enable the different spheres of government to manage their own disasters. We've got a situation in the Western Cape that we've got 2 fault lines that can cause earthquakes. We've got a nuclear facility built very near to that fault line. But then we've got a catch-22 situation that the Council of Geoscience is a parastatal. They're not doing work for free. So we can't, if we want to, we actually need to get a government institution to pay for that research. And as you know, research is very expensive. The question that I want to pose is, what is the chances of getting GEM more involved in the Western Cape? Use it as a pilot study, and I see already there's people of geoscience on your team, and I see Andre Kiko is also on that team. The only person I missed here is Dr. Chris Hardnedy. That's also, and we've got, due to the tsunami in Japan, we had several questions that's posed to our disaster management fraternity. What's the chances of a tsunami happening in South Africa, specifically in the Western Cape, because we also got a nuclear facility. And we were posed with a lot of how to answer that, and we don't have always the answer. So hopefully it will never happen to us, but just what if it happens to us, what will we do then? So it's quite a broad question, but hopefully we can get some direction. Thanks a lot.
Thank you. I'll start perhaps with the first of this set of 3 questions, and I will start with Helen.
So you correctly stated that within our framework we're calculating physical risk, and the outputs of our software include loss exceedance curves and average annual losses. And so to be able to calculate them, we need to be able to describe the key building typologies, the characteristics of those buildings, the value of those buildings. So to address this, one activity that we have deployed is to develop a global building taxonomy, which is a common classification scheme to describe buildings in all countries around the world, so that each of the regions are describing their buildings using the same terminology, the same attributes which are described, those attributes which influence seismic performance. So these guidelines, this taxonomy is already available on that Nexus platform. So one thing we ask regional experts to do is to review this taxonomy. Can their buildings in their region be described using this classification scheme? We're also collaborating with the World Housing Encyclopedia, which is an initiative of EERI. They ask regional experts or experts from different countries around the world to describe their building types. And this is something that we do within the regional programs. Ask civil engineers, structural engineers within the regions, what are the most common building types in your region? How are they described? What is the value of those building types? What is the seismic performance of the building types? So, yeah, I think we need more engineers in the Sub-Saharan African regional program. So if there's anyone here that wants to join, we very much welcome that, to help describe these buildings and do better estimates of physical risk and losses.
Can you link up as well to the issue of the economic losses and how that information?
So that's why we need to understand the value of these buildings. What is a typical construction cost? What is a replacement cost per meter squared for different buildings, so that we understand what is the value of the buildings, and then describing the fragility functions help us to understand what is the probability of different levels of damage, and then we relate that damage to a repair cost, understanding typical repair costs for different levels of damage.
Sure, I mean, but this is the theoretical aspect of it.
Yes.
The practical aspect where probably each of these buildings needs to be physically surveyed and classified. Is there some kind of initiative towards?
So for those who could not hear because there was no microphone, so the question is, from a conceptual viewpoint, everything that was being said, it finds the agreement of the questioner, as it were. But what about the need to then go, in many cases, and study the individual buildings, or at least have a more field survey type of activities in order to gather that necessary information that is not always available in regional or national data sets?
So we are developing tools for collecting building by building information, so these mobile phone applications, so you can do ground surveys to collect information to understand the characteristics of the buildings, and so these will be deployed within different regions.
Okay, thank you. So I'll pass to the second question, which related to the issue of should we be more involved with politicians, but connecting more closely with politicians in order to really be able to increase the interest in this type of activities. And I will perhaps put Mohammed El Gabri on the spot here, because he did not speak, and he's someone that he has been more involved in political activities that you would imagine, and I'm particular making reference to the turmoil of some months ago in Egypt, and Mohammed was actually one of those individuals that was on the square, in the square where things were happening. And so I believe that he can start by answering that question. Mohammed?
Thank you, Rui. Maybe I have to answer to the question. I won't say the first one because nobody will like it. It will be more radical because it has to be with my political point of view. But if I will speak on behalf of my group and behalf of what we are doing in North Africa, yes, we are trying to engage what you can say scientific political persons. Somebody like advisor for ministers and advisor for the cabinet, and they have some scientific background. So we are trying to engage these persons in our activity. So they can guide us what is the language they need to hear, because, you know, politicians doesn't like, for example, PGA. He have the big ground acceleration. What I have to do with this? He has to do with US dollars. He has to do with number of dead people. So that's what we are trying to do, to find the language that we are going to talk with the decision maker and to have somebody from insiders that can be inside the process we are doing. So in an example, in Egypt, we have the advisor for the cabinet. In Algeria, we have the same. In Morocco, they are somehow connected. So we are trying to engage these people. And I think, as well as Atalay was trying to do the same in Ethiopia and also in the African Union, is try to give this more general presentation to the politicians. What is the real risk we have? What you cannot, what you didn't experience previously because you didn't have this type of building. We were discussing that maybe in some areas of Africa you have historical earthquake, but at that time you didn't have the building or the structure which records this. People were in a very fundamental houses which has not been affected. Some areas you have records. For example, in Egypt we have some records from BC in northern Algeria they have, but this is very, very limited information, limited to the place. And that's where we have to also incorporate geology, to incorporate active tectonic activity. I have to go back to the first question was asked about including scientists from outside of the region. In fact, the coordinator for the North Africa, Mustafa Maghraoui, is Algerian who is working in France. He's a French Algerian. And we have also some collaborator from USA. We have some contacts with Amr Nashai. He's quite busy, but he showed his interest as well to help, but he's not anymore. And we have Fouad Boualem as well. So we are trying to get these people because they wanted to help the region, in fact, and they can contribute a lot.
Thanks, Mohammed. And still on this issue of bringing the political forces into play, perhaps I would now put Nicole Keller on the spot. She was recently been involved in a G20 preparatory meeting that was held at OECD, if I'm not mistaken. And as you heard yesterday, this joint Mexico government and World Bank publication that was released on the occasion of the G20 meeting, and the GEM initiative was mentioned there in 3 different chapters. And Nicole, do you want to add anything to this discussion in terms of the involvement of the political will, if you will, in this type of activities?
Yeah. I think it's important to mention first of all that we always say that GEM is an independent organization, and we actually try to bring everyone together. So it's structured as a public-private initiative to begin with, so that we have the balance between what is really needed out there, and then we have the experts, let's say, coming in from the bottom up, and so we have a real collaboration going on with hundreds of people. And I think because what Francis was also saying yesterday, in the past 2 years we have really gotten the support of all these people and seen that things are happening, and many people see that JAM is creating momentum, is really managing to get the different interests and the different people together, and that's why we are being asked also to serve as a kind of to explain how we are doing it, and maybe be of inspiration to other countries, other people that are dealing with the same issues in an international level. So the G20 meeting where I was at was to talk about actually the state of the art of risk assessment and risk financing. It was good to be able to discuss with representatives of the ministers of finance how we are trying to establish these standards for risk assessment that they can then use in order to assess their risk and to really have quantitative support in order to develop strategies for, but not only themselves. The platform that we're developing will be able to facilitate many types of users in order to assess their own risk. So then it's a kind of top-down, bottom-up. So everyone can do their risk assessment, and we can learn from each other. We can start to discuss with each other. So it becomes much more open and much more a collaborative risk assessment effort.
Thank you. The third question sort of ruined my job as master of ceremony, because normally I'm the one who decides who answers the question. But of course, the third question immediately started by saying, this is a question for Ray. So, Ray?
Yeah, I guess we're all interested as to whether we could be hit by an earthquake right now or a tsunami. So, good question. And in fact, when the 2010 World Cup was taking place here, there were some alarmist reports in local newspapers about the risk of the beautiful World Cup stadium, which is just a few kilometers down the road, being hit by an earthquake. So what is the situation? Well, the biggest instrumentally recorded earthquake in South Africa happened in 29th September 1969 at Ceres, which is 70 or 80 kilometers from here, and it was felt in Cape Town. I was a schoolboy then, and I remember rushing out of the home and feeling it. So we could feel something like that. It could really happen. And in 1809, it was in December, there was an earthquake. Of course, it wasn't instrumentally recorded, but it was felt. It's described in the literature, and it happened in Milnerton, which is about 15 kilometers from here. There was a rupture on the surface. There were sand volcanoes. And if that had to happen to repeat itself right now in that area around Milnerton, there's quite a lot of sediment and things like that. The shaking could be quite severe, and it could cause a significant amount of damage. So there is certainly an earthquake risk here, which you need to manage. It needs to be on your plan. Tsunamis, following the Indian Ocean tsunami of 2004, we did with colleagues around the world, did studies of what are the chances of that wave, of there being a tsunami here. Certainly that wave, it reached Cape Town, it was measured in the tidal gauges, but it was very gradual. Nobody ever really saw it here, but it was measurable. And our modeling shows that if there had to be another one, in either in Indonesia or on the South Sandwich Isles, which is on the southern tip of South America, that's where the nearest truly great earthquakes are, it's unlikely that it would cause a significant wave here in South Africa, and we'd have lots of warning. And since that time, the Indian Ocean tsunami early warning system has been established, and South Africa is a participant in that. So we should get warning in time. Elsewhere on the South African, well, one of the other ways you get tsunamis is if you have a submarine landslide. You have our rivers bringing sediments onto the continental shelf, and every now and again you can have an avalanche under the water, and that can cause a local tsunami. Now, fortunately, around Cape Town and the Cape, your continental shelf is quite broad, so it's unlikely to happen here. But further up the coast towards Durban, your continental shelf is very narrow, and it could happen there, though we've got no recorded incident of this happening off the South African coast, but our recorded history is quite brief. It's only a few centuries, and certainly similar phenomena have happened elsewhere in the world. So that is a concern for disaster managers in Durban. And then your last question is how do you pay for these kind of services? Now, I work for the Council for Scientific and Industrial Research, and the Council for Geoscience is also a science council, and here in South Africa we have this system where we're not fully funded by the parliament. We get a certain amount of income by parliamentary grant, and others we have to charge for our services. I suppose the only I think it's a pity because, I mean, the taxpayer pays for these organizations. I suppose the one, I think this is a local problem, but the head of the seismology, the Seismic Hazard Assessment Group in the Council for Geoscience is here in the audience, and I can make sure you meet each other afterwards, and maybe you'll be able to know if I work out who to, which budget to try to, or which minister or which member of the executive committee to speak to try to make this possible. That's the best I can offer.
Thanks, Ray. Some more questions from the audience?
This is just an observation, how to involve politicians or how to see the political will. See,
do you mind presenting yourself to the audience?
I'm SP Vasudeva. I'm from National Disaster Management Authority of India. See, the politicians, especially in democracies, are accountable to the people. If you go to them for money in doing research in disaster management, funds in disaster management, they may not agree. You have to go to them to tell them that if such disasters occur, the damage to the people will be so much. Our involving politicians should be that what we are doing that will benefit the people in this way or that way. Instead of going to them for money for research, they may not give money for research, but when you go to them and tell them that such a disaster will have impact on the people they represent, I think they will come forward.
Thank you. Thank you. So this is more of a comment rather than a question, and very welcome indeed. And this is something that we've also when we presented the session yesterday, we want you to contribute to this session. So it does not necessarily mean that it has to come in the form of questions. It can be in the form of suggestions, of comments, of clarifications, such as the one we just heard. So back there, yes, please.
Okay, thank you very much for the wonderful opportunity. My name is Tebogo Haulaulu, South Africa, Limpopo Province. The question that I would like to ask, I'm made to believe that maybe it has been asked already, but that question is about losing the scientist because of the greener pastures. Now the question is, we have identified the risk that we are spending too much money in the continent, but unfortunately people are living for greener pastures. Is there any strategy, the retention strategy, that is available in order to retain those academics or the scientists? Thank you.
Thank you. The question, so the question has been addressed already, but we'll may give the chance to spend another couple of minutes on that, but we have discussed it a little bit. Can I have the microphone? It's coming.
Yeah, my name is Loy. So I may be asking the wrong question, but let me ask it anyway. I'm somewhat familiar with the work of GEM, and it's important to assess earthquake risk and understand it better. But how much work are you doing on reducing earthquake risk as in improved preparedness and earthquake vulnerability reduction and improved building standards and all the application side of the business? Somebody can talk a little bit more about that.
Yes, thank you. Another question before I pass on to the panel? Yes, over there, please.
My name is Daniel Mtamena from Zambia. I'm a seismologist at the Geological Survey Department. My question is as regards GEM's policy on data. Does, when an institution contributes data to GEM, does this data become a public domain? I would like to find out on that one.
Thank you. Thanks for that. So I think we can turn to the panel now. We did discuss already the issue of difficulties in retaining the capacity. If any member of the panel wants to add something to it, then we can. Otherwise, we'll pass on to the next question. Anybody wants to add? Okay, Mohammed.
In fact, the mind bleeding problem is a serious problem in Africa as a whole. But what we are looking for in near future, in last decades, we had trainings. We had only trainings. So when you have training, you are not building a real infrastructure. What we are looking for is to be engaged in international projects. So in that way, we can enhance the infrastructure for the institutional work more than training one person and this person has a better opportunity in a different place. That's what I hope in the near future we have. We have a more regional and international scientific project where the institutions in developing countries are not a data providers. They are part of research. There is PhD students doing, there is research going on in their institution, so we can have a forward ahead. But right now, still we are in the phase of training. Everything is offered to developing countries. We can train you. I think that's enough of training. We are looking for partnership where we can have more and more cooperation and benefits for both partners. Thank you.
Thank you. Thank you. Ray wants to add something.
Just very quickly, in Africa, Ray, our model is that we have sandwich agreements and partnership agreements with foreign universities. So if you send a student over for 5 years to the US, the chances are they will not return to Lisbon, to Luanda or Lagos. They will stay in Paris or Houston. So we have partnership agreements where we do most of the training in South Africa or in an African university. So while they're doing their PhD, they can be sharing that knowledge and be working locally and build up our capacity locally. So that is the model we are working on now with some success.
Thank you. Thank you. If we can pass on to the question regarding how much GEM is doing or not doing in terms of real risk mitigation types of activities. And perhaps I would again put Nicole Keller on the spot there. Nicole, do you want to comment on that?
Yeah, I would like to. I think that what we are trying to do is, this session is called actually working together to assess risk and understand risk. But it needs to be clear, we're not a public-private partnership to just assess the risk and stop there. We are working on decision-making support tools. The platform will allow you to overlay different layers of hazard and risk to facilitate understanding. So it's very much geared, I guess, towards risk mitigation. But what we find very important is that we do not do everything, because there are many organizations working on risk mitigation. The World Bank is obviously a large organization working on that, but there are many. And we have them actually on our board, on our governing board, as advising partners, because we want to make sure that we link up, that we make the links in the correct way, and that we facilitate all those disaster risk management organizations that are in need of the information. We just had a beneficiaries needs research, which was carried out in 11 cities around the globe, that looked into the needs of non-experts, people that want to help their communities in mitigating their risk better. And we are trying now to work out how that research can help us to guide better what we are doing, the tools, the resources, the infographics, the information that we want to provide, but never alone. We don't feel that we should cover the whole range, let's say, that we should send GEM engineers out there to tell you how to build better, but it's about you coming in and using the information to build better, to hold your the people that you want to hold accountable for mitigating the risk, but also for yourself to make decisions based on the information you find there.
Thanks, Nicole. No other members of the panel are raising their hands, so I'll pass on to the next question, which regards GEM's policy on data. And given that Helen was talking about global data sets and the collaborations between those and the regional programs, perhaps, Helen, you could comment on this?
So I mentioned some global databases, an instrumental catalog, geodetic exchange. So these global databases that we've been investing in and will be publicly available, will be open. They'll be available through the OpenQuake platform. So these databases will be open, but developing further these databases and interacting with regional programs to enhance the databases, it's down to the owners of the data, the regional owners, to decide whether they want that data to be public or to be private. So when you upload data to the OpenQuake platform in the future, when you use some of these tools that I mentioned, even for collecting information on buildings, when that comes to be uploaded to the OpenQuake platform, it's down to the user to decide if they want that to be private or perhaps just shared within the region, or to be openly available to the rest of the community.
Thank you. Any other comments?
Yeah, I guess we obviously hope that everyone will start to see the benefit of better databases, especially when we go down to the local scale. The more data there is, the better risk assessments for everyone. So we hope that once people see the tools, see the platform, can work with it, see the value of it. So we obviously hope that then the data will start to flow in and we can all make use of it. We can share our experiences and learn from it together. But definitely everyone has their own say in it.
Thank you. I think we can have a final set of questions or comments coming from the floor. So any arms in the air, hands waving frenetically or frantically? Yes, please.
Yeah, maybe I may make a comment.
Can you present yourself to the audience, please?
I'm Richard Wambura Ferdinand from the Department of Geology, University of Dar es Salaam, Tanzania. I may make a comment regarding the situation in Africa. Actually, there is a little bit of fragmentation between the science part, the engineering part, and the disaster management part. How the way the data is passed from one unit to the other, that's where I think there is a missing link. You may find the disaster management unit doesn't depend on the engineering part and the scientific part. The same applies with regard to this situation. You may find the engineering part is not directly coupled with the scientific part. So to some extent, globally, we may feel there is a link, but locally, within our individual countries, you will find that link is missing. Maybe one of my opinion, or the question that I can pose to Jem, perhaps either they may try to establish the link through the global channel, or the local unit may try to do as much as they can to try to link on that aspect. Thank you.
Thank you. Any other comment or question, final remark? Please. Thank you.
Thank you. My name is Hiroyuki Hino. I advise the Prime Minister of Kenya on economic and financial matters. I came to this session so that when I go back to Nairobi, I could tell Prime Minister, now Prime Minister, we have to take earthquake much more seriously when we are thinking of, in particular, about nuclear power plant in the country. I really wanted to get the information from this session so that I can convince the Prime Minister that's the case. My sense is that after listening to you very carefully, I did not get that information. I don't think I have enough listening to you to go back and to Prime Minister, look, we have to do it much more seriously. I'm sympathetic to the calls coming from Japan, but still, I don't think I got that information from you, talking to politicians. So I wonder if there are any other ways for you, like Dr. Attlee, to present that information in such more sort of a policy-relevant way. You say we had, earthquake 55 years ago here and there, of course, but then it's not really convincing if it's not immediate enough. I'm not sure if I'm communicating with you. That, for example, in Japan, you say within the next 25 years, the chances of having earthquake of magnitude more than 7 is 55%, for example. This is an example. That then one can relate the risk more clearly to policy making. So my question to you really is, don't you have some other ways to present the information that you have on Africa, the risks in Africa, so that the people like myself can be a much more effective intermediary in conveying that, the message actually you are trying to transmit to the policymakers in Africa. Thank you.
Thank you. Any very final question, remark before we pass on to the panel? No, so we'll go on to the panel to close this discussion. And so the first comment regards the issue of trying to establish the link between the scientific, engineering, and disaster management community, and if that is something that can or should be done at global level, or if instead is something that can or should be done through the local players. So let me see, Atalay, can I put you on the spot on this one?
To comment on what Richard has raised, the scientists, engineers, and the hazard mitigation organizations, these three of them, they do exist in every country almost, and the link is also there, but the link is weak. Recently, we were asked to be involved in a code revision committee in the country, and this happens once in 10 or 20 years. Otherwise, we don't have any communication with engineers. So the engineers just want that PGA value in a certain turn period, and once in a while. So the link is very weak. It shouldn't be like that. For the disaster management unit, actually, we also once in a while communicate with them whenever something happens. So I wouldn't say, actually, I highlighted this during my presentation, that there is no a structured framework for mitigation success whenever any crisis arises to alleviate the problem. So maybe we have to work more on that to have a stronger interaction among this. And I'm not sure if GEM can go that far. Maybe someone can correct me. So it's a link, I mean a weak link, but the link is there, and we have to work the local people in Sub-Saharan Africa, and my other colleagues have to interact and engage the engineers and engage the people involved in hazard disaster management unit. I have two colleagues here in this audience also from Ethiopia, for instance. So once in a while we interact, but I wouldn't say the interaction is strong and up to the standard. We have to work more on that.
Thank you. Just a comment on to the final remark, and I'm not quite sure that the objective of this session was that of providing that sort of of material and of information that you were referring to, but that is certainly a very relevant issue, and perhaps there is certainly, you have a point in the sense that perhaps we could take we could reflect a little bit more about that, and I can see that Ray's waving, and so Ray.
No, I'd just like to comment. There's a seismologist from Kenya in the audience, and I can connect you with her afterwards. And also, there are people from South Africa who've worked on the seismic hazard assessment for our nuclear station planning operation. And if you like, I can connect you with them after the session.
But, Helen, do you want to comment on that?
Just a quick comment that this is exactly why we have a regional program in sub-Saharan Africa, so we can provide these types of outputs that you need to take to your governments and convince them. So keep watching the GEM website, the collaboration platform.
Yes, I would also argue that, as has been mentioned before, that the objective, and I think Nicole was alluding to it earlier on, that the objective is to engage the stakeholders that you were just referring to in the process of defining what information goes out and in which format and through which tools. So this is definitely the direction that wants to be followed. I think I will. Marco is raising his hands. I'm not quite sure why, but he's not allowed to intervene now. We have to close. This was excellent. I can tell you that we've stopped the presentations and initiated the discussion, the roundtable discussion, well, 20 minutes before the opposing session on the other door, and I was checking them out, which means that we did have quite a lot of discussion and interaction. That was the objective. So thank you very much for all your contribution. And as Helen was saying at the end of her session, do pass by the GEM booth at the exhibition space to discuss things more. So thanks again, and well done to everybody.